In this video, we will see how to define recursive functions in Python. As we discussed earlier, there is no syntactical difference between the regular functions and the recursive functions. Recursive functions are the functions which are called by themselves. Other than that, there is no syntactical difference between the regular function and the recursive function. These recursive functions are defined in the same manner how the standard functions are defined, and they are also called in the same manner how the standard functions are called. But the only difference is these recursive functions are either directly or indirectly they are calling themselves. That's how they are known as the recursive functions. In this video, we will see some of the example functions which are defined in the recursive manner. Consider the function definition fact. So actually this function receives one parameter and returns the factorial of that parameter. And here this function is a standard function which is a non-recursive function, and this function computes the factorial of a given number and is designed in the iterative manner. As the factorial here computed in the iterative manner, so this function is known as the iterative function. So we can call this function by using the function name and by passing a value to the function as a parameter. Now let's execute this code and see. So on executing this code, so you can observe that the function is returning the factorial of the parameter you are passing, that is 120. So the parameter you passed is 5 and its factorial is 120, so the function is returning 120 as a value. Now let's define the same function in the recursive manner. The recursive function always shall contain the terminating condition or the base condition. Whenever the n value is 0, then the factorial of the value 0 is 1. So you can directly return that value. Or in the other case, whenever the parameter is a 1, in that case also its factorial value is a 1. So in that case also we can return the value 1 directly. So this can be considered as a base case for this recursive function factorial. So in the other case, when the parameter that you are receiving is neither a 0 nor a 1, then you need to compute the factorial of the number recursively. So that is multiplying n with n minus 1 with n minus 2, so on and so forth up to 1. So in this case we can have a recursive call. So you can design the recursive function call here in the else part. You need to multiply this n value with the factorial of n minus 1. So here if you observe, this function call calls the same function with a lesser value. Again that function calls the same function with a lesser value, and this is repeated as long as n value is neither a 0 nor a 1. Whenever the value of n reaches a 0 or a 1, in that case it returns a 1, and in that case the function will not be invoked anymore. So that is, in that case the recursive function call is not executed. So if you observe this function definition, the fact function is called inside the function itself. So that is, the same function is called inside that function. So such functions are known as the recursive functions. Now let's call this function. This function can be called how we call the standard function, by using its name and by passing the parameters that are required by the function. And now let's execute this code and see. Now if you observe the result, so you are getting the factorial of the number you are passing as an argument. So the factorial of 5 is 120, so the result it is displaying as 120. So in the previous case, whenever we use the standard function to compute the factorial, or in this case the result is all the same. The only thing is now the code is more readable and compact. So that is how recursive functions can be designed. The recursive functions are the ones which are called by themselves. Now let's define one more function. Now we are going to define a function to compute the sum of the numbers from 1 to n, and the function we are going to define is in the recursive manner. So here if you observe, sum is the function name and n is the parameter that is received by this function sum, and the base condition or the terminating condition in this recursive function is n equal to 1. That is, whenever n is 1, then you need to return a value 1. So that itself acts as a terminating condition for this recursive function. Whenever the value of n is greater than 1, in that case you need to call the same function. Whenever the value of n is greater than 1, in that case the execution moves to the else block and you are returning n value plus the sum of n minus 1. That is, in this case you are calling the same function with a lesser value. So sum of n minus 1. So how do you get the sum of n values? So when you add n to the sum of n minus 1 values, so you will get the sum of n values. In that manner you are calling the same function again and again as long as the n value reaches 1. So that is how you can implement this function in the recursive manner. Now let's try to call this function and see. So I'm going to call this function sum by passing the parameter value as 50. You can observe here we are getting the sum of 1 to 50 values whenever we call this function sum. So that is how it is possible to define the functions in the recursive manner. Recursive functions makes our code look much readable than the standard functions, and certain applications when defined using the recursive functions, they become very compact and more readable. Now let's call this function which is defined as a recursive function by passing 1500 as an argument and see what happens. So here you can see, so maximum recursion depth exceeded in comparison. So that error we are getting. So in Python the problem is the maximum number of times a function can be recursively called is set to 1000. So here we are passing 1500 and the function has to be called for 1500 times. So which is violating that rule. So that is how it is generating a recursion error. So to avoid this, what we can do is we can import the module and we can set the default recursion depth to 1500 or whatever the number we would like to. So we'll do that now. To make the recursion depth for more number of times, so what we need to do is we need to import the sys module, and in the sys module there is a function with the name set recursion limit. In the sys module we have a method set recursion limit which takes the maximum number of times a recursive function can be called. So here I am setting this limit to 2000. So as we actually need it for 1500 times. So this 2000 is actually greater than 1500. So we expect this code to execute now. Now let's execute and see. Here you can observe that we are able to get the result without any issue, even if we call the recursive function for more than 1000 times. That is how in Python it is possible to set the limit on the number of times a recursive function can be called. Now I hope you understand how to define recursive functions and how they are helpful to improve the readability of the code or to solve more complex problems using recursive functions. And in addition, we also understand how to set the limit on the number of times a recursive function can be called in Python. Thank you for watching this video.